Simplest possible optical instrument, the magnifier. If I have a converging lens, we can use that to magnify things. And the way you'd use it is like this. If I'm looking at a piece of paper and I bring it in at about 25 centimeters, that's about as close as I can get this to my eyes and have it stay in focus. Okay? That's typical for people, and that's what we use as our standard value. 25 centimeters, that's it. But if I use a converging lens, put that in front of my eye, I can get it much closer. Oh yeah, now I can see it right here. So it turns out the magnifier is not actually magnifying the image. It's just letting me put it closer to my eye, and so it looks bigger. It takes up a bigger angular extent. That's how a magnifier works. And we have a question today that involves this very lens and the magnification that's possible with it. Let's take a look. Let's take a look at the question. What is the magnification of a 20 diopter lens that is used as a magnifier by a person with a near point of 25 centimeters? Well, there's two pieces of quantitative information in this passage. It's a positive 20 diopter lens, and that tells us it's a converging lens, and the power is 20 diopters. And it's being used by a person with a near point of 25 centimeters, which is typically what we assume. Well, when we do a calculation with the lens, we don't want its power. We want the focal length of the lens. We need to know what is the focal length. And if I have a lens with the power of 20 diopters, what is its focal length? We'll give you some choices. Okay, remember that the power of a lens is defined as 1 over the focal length, where the focal length is in meters. And so that tells us that the focal length in meters is just equal to 1 over the power in diopters. In this case, that's 1 over 20, so the focal length is 1/20th of a meter, or the number that we use in this passage, the focal length, 0.05 meters, or we can also write it as 5 centimeters. That's going to be a crucial number for us. Now, we were asked to find the magnification of the magnifier. But remember, as we said, the way the magnifier actually allows you to magnify things is it just lets you get closer. Let's think about how that works. If I'm looking at something with my eye, and here's a simplified model of the eye, there's a certain distance that I can get to called my near point. And in this case, we were told to assume that the near point is 25 centimeters. That's as close as the eye can possibly get. And so any closer than that, the lens of the eye can't bring the image into focus. So if you use a magnifier, and I put the object right at the focal point of the lens, that tells me my eye can just focus as if at infinity. My eye's focus as if it's focusing on a distant object because the rays are parallel. That's what we'd expect from a distant object. But the object is, in fact, very close. It's just at the focal distance of the lens. So here's what we get. The near point of the eye is 25 centimeters. So the eye is focused on the object as close as it possibly can, and the distance is just 25 centimeters. But now a magnifier is put in front of the eye. The eye will focus as if on a distant object. The object is right at the focal point of the lens, so it's only 5 centimeters away. So the magnification, how much bigger does the object appear, is just the ratio of the distances. It was 25 centimeters away. Now it's 5 centimeters away, and so the magnification is 5.0. The object appears 5 times bigger than it did. And it's not that it's bigger, it's that it's closer. Let's take a look at this and see if it makes sense for this particular lens. We calculated that it would provide a magnification of 5, and here's why. If I go to my standard near point, 25 centimeters away, that's about right. I put the lens in front of my eye, and in fact, I can bring it into a distance. If I'm going to estimate this distance, how close can I bring it? It's about 5 centimeters. That's exactly what we calculated, which makes sense. So normally I had it 25 centimeters away, but I can bring it 5 centimeters away. It's closer by a factor of 5. The angular size of everything I'm looking at is bigger by a factor of 5. And so it's a magnification of 5. And so our answer works. But that was me telling you what it looks like. Let's use the camera to show you what this actually looks like in practice. Here's a piece of paper, 25 centimeters from the lens of the camera. Now if I move it closer, the text gets bigger because I'm closer, but at some point it goes out of focus. Well, that won't do. So what we'll do is this. We'll go back to 25 centimeters away. I want to have a close-up view of the piece of paper so it looks bigger. Now I'll put a lens in front of the lens of the camera. This is the very magnifier that we saw before. So we'll bring that lens in. Now I bring the piece of paper closer. And what happens is this. It comes back into focus, and it comes back into focus at a much closer distance. And that allows us to have a close-up view of the piece of paper. So you've seen for yourself, magnifier doesn't actually magnify, it just lets us get closer. How much closer? This lens lets us get closer by about a factor of 5. And so it provides a magnification of about a factor of 5, exactly as we calculated. Not a surprise, physics is about the world around us.